Systems of linear inequalities. At the end of this lesson, you should be able to answer the question, how do I show the solutions to a system of linear inequalities? So, on your screen you see a blue and then a red inequality. On the left, y is greater than x plus 2. If you recall, when you graph this, because it's greater than, you draw a dashed line. The line will cross at 2 and has a slope of 1, and since y is greater, you shade all the values above that line. So the half plane that's shaded represents all the ordered pairs that fit this inequality. Whereas for y is less than or equal to negative 1/2 x, that would be a solid line crossing at 0 with a slope of negative 1/2, so you would shade everything below that line. So in the red solution set, everything on the line is a solution as well as below it. With the blue, it would not include anything on that dashed line. Well, if I merge these two solution sets and make this a system, what I'm really asking is, where do the two solution sets overlap? Well, I think you can see that they overlap in this triangular region to the left. Everything in here would be a solution to this system. So you could name any ordered pair in here as a solution. For instance, I could say that the ordered pair negative 5, 0 is a solution. That's right here. Anything on this solid line would be a solution. On the dashed line, it wouldn't be a solution, but it would be everything in this triangular shaded region. Okay, so let's graph the following inequalities and look at where their shaded regions overlap. So I'm going to do y is greater than or equal to 3x plus 2. So this is going to cross at 2, and it has a slope of 3, so we rise 3, run 1, down 3, left 1, down 3, left 1. This would be a solid line because it's equal to, and then it says y is less than or equal to, so this would be shading below the line. I'm just going to put a few marks going straight down from that line so I can determine where my regions overlap. The second one, y is greater than negative x plus 3, so this crosses at positive 3 and has a slope of negative 1. This one is going to be a dashed line. And then I have to determine where I shade. Since y is greater than, the greater values of y would be above this dashed line. So now I can see where my regions overlap. I'm going to get rid of this area, and the shaded region would be in here. So any ordered pair that falls in that shaded region would satisfy the set, or the system rather. So what you could do to check it would be select any ordered pair, such as the point 3, 1, and plug it in for x and for y into both inequalities. If it satisfies both of them, that will verify that that is the correct shaded area. Okay, now practice with number 2, and one of the things you should notice is that top inequality is not in slope-intercept form. So you're going to need to start by converting this to slope-intercept form by subtracting 4x from both sides, which would result in 2y is greater than or equal to negative 4x plus 8, and then divide both sides by 2, which would be y is greater than or equal to negative 2x plus 4. So now I can graph my two lines crossing at 4 with a slope of negative 2. This would be a solid line, and I need to shade the region above because it's greater than. So I'm just going to put a few little marks going above. That will help me determine my overlap shaded region shortly. And my other line crosses at negative 3 on the y-axis and has a slope of negative 2. So down to right 1 or up to left 1. Now, hopefully you notice that the slopes of these lines are the same. This one would be a dashed line, so I can see that my lines are parallel, and they should be because they have the same slope. This says I need to shade where y is less than. Well, that's going to be below this line. So I need to ask myself, where do these two regions overlap? and I can see that they don't overlap. So what is the solution set for this system of inequalities? Well, there is none. There is no solution here because there is no overlap shaded region. Three and four are just additional practice problems for you to look at some special cases of lines. They're not difficult. Y is less than x plus 3. Well, that's going to cross at positive 3, and it has a slope of 1. So this will be a dashed line because it is less than. My overlap, or my shaded region, is less than this. I'm just going to put a few little marks below so I can then see where it will overlap. And then for y is greater than or equal to negative 4. That has a slope of 0. So it will be a horizontal line fixed at negative 4, like this. And that kind of slanted slightly up, but it should be perfectly horizontal. And I need to shade the region greater than that. So my overlap shaded region is going to be here. So it's going, the solutions will be anything in that shaded region or on the red solid line. Solutions on the blue dashed line would not be a solution to the system. In number 4, you need to change the top inequality to slope-intercept form, so I'm going to subtract 2x from each side, which results in, continue my work up here, negative y is less than or equal to negative 2x plus 3. I need to divide each side by negative 1, and when I do that, I have to remember to reverse the direction of my inequality symbol. We'll switch to positive 2x minus 3. Okay, so don't forget, anytime that you multiply or divide by a negative value, you must still continue to reverse the direction of your inequality sign. So this has a y-intercept of negative 3 and a slope of 2. So this is a solid line because it is equal to, and I need to consider my shading. I'm shading above this line, so straight up from it. For x is greater than or equal to 3, well, hopefully you recognize that this can't be written in y equals mx plus b form because it is a vertical line fixed at 3. So here's x equals 3. Right here, vertical line, and it would be a solid line. Now when I do my shading, x is greater than or equal to 3, I have to consider where the x value is greater. That would be to the right of the line, so over here. So where does it overlap is going to be in this little triangular region up here at the top. And I always erase where there are no solutions. You'll see that in some cases they won't erase, they will just make the overlapped region darker, or also known as the feasible region. So both methods really are acceptable. In example 5, you are asked to create the system for the given graph. So I'm going to isolate or focus in on the blue dashed line first. I'm going to write this in slope-intercept form. So I determine where it crosses the y-axis, which is 4. So I know it's going to be plus 4. I need to determine my slope by counting. It seems like it is going down to right to, which would reduce to negative 1. So negative 1x, or just negative x, and then I look at where it's shaded. Well, it's shaded below this line, and since it's dashed, it's going to be just y is less than negative x plus 4. All right, so now I'm going to focus in on my red line. This one is solid. I'll consider, I know it's going to have to be greater than or equal to or less than or equal to, and I'll decide which in a second. This one also crosses at positive 4. I need to figure out my slope. Seems to be rising 2 and run 1, up to right 1, up to right 1. So that is a slope of positive 2. Now, where is it shaded? Shaded straight up from this line. So that's greater than, and since it's solid, it's greater than or equal to. So there's my system that matches that graph. Okay, for our final example, we're going to look at an application. It says Jose works at the Leola pool. He earns $12 an hour as a lifeguard and $6 per hour in the concession stand. The pool manager will not let any employee work more than 20 hours per week, and Jose needs to make at least $36 a week to pay for the gas in his car. All right, so First thing I'm going to do is define my variables, and I could use X and Y, but I recognize I don't know how many hours he works at each job. So to make it a little bit more logical, I'm going to use L for the hours worked as a lifeguard and C for the hours worked at the concession stand. So I need to write a system. So for my first inequality, I'm going to consider the amount of money that he earns. The first one's going to be all about money. He gets $12 per hour as a lifeguard, so 12L, plus he works a job works in the concession stand, so plus 6C would be, he needs to make at least 36, so this needs to be greater than or equal to $36. So that's an inequality all about money. Now, the pool manager has some conditions. His hours work cannot be more than 20, so L plus C, the 2 hours, have to be less than 20, not less than or equal to, let me read that again. He will not let any employee work more than 20, okay, so it would be less than or equal. He could work 20, but no more than 20. There's my inequality. So what I need to do for this system is change them both to slope-intercept form to graph them, or I need to use my intercepts to graph them. So I'm going to put some labels on my coordinate plane. So I'm going to put the hours as a lifeguard down here, lifeguard hours, and I'm going to put concession stand hours on the y-axis. And I'll say hours at concession. It's not a great job labeling, but it'll help me get my graph. So I think I'm going to actually do this one by my intercepts. So my x-intercept for the top equation, if I just kind of cover up, or also known as the L-intercept, if I cover up the C, I would, if I cover this up and then divide both sides by 12, I would get that L equals 3. And then to find the C-intercept, if I cover up this, I'd have 6C equals 36. 6C equals 36, and divide both sides by 6, I get C equals 6. So it crosses at 3, and this is counting by 2s right here. Crosses at 3 on the L, and at 6 right here on the Y, also known as the C-axis. So that's going to be a solid line, and I want to graph where it's greater than or equal to. So it's going to be greater than or equal to up above this. Above this. All right, the other one, just to kind of show you a different way, would be to change it to slope-intercept form. So I'm going to have C, since the C is like my Y. I'm going to subtract L from each side. C is less than or equal to negative L plus 20. So this is going to cross at 20, have a slope of negative 1. So that's going to be all the way over here for slope of negative 1, and it's shaded below that. So anything in here is going to be a solution. Now, one of the things that's a little bit misleading, okay, is it's not necessarily every possible value, because how do you work like 2.555555 hours, something like that? But we do typically shade this region in here, and you might be asked to give one possible combination of hours. So we could say that he could work, this ordered pair right here would be 8 hours as a lifeguard and 6 hours. This would be 8, 6. So if you put labels on that, 8 hours as a lifeguard and 6 hours at the concession stand. You could choose a different combination. You could say this is 2 hours as a lifeguard and 14 hours at the concession stand. So all of these in this shaded region would give you the possible combinations that he could work and make over $36, at least $36, and wouldn't be going past the 20-hour restraint.